Hello everyone. So today we will continue the series of classes of linked list today as well. So all the important links and everything I will mention will be available in the description section as usual. So if it is your first class, then I will request you for a prerequisite, that is the first three classes of Linglist. So the first three classes will be considered as a basic class. So today we are almost at the end, and I hope now onwards, from after today's class, you will be able to draw the basic programs of Linglist. Obviously, you have to practice a lot. It is not like just watching my classes will be enough for just writing the programs. Of course not. You have to try class by class, exercise by exercise. I have mentioned one of the exercises. Even the link will be given in the description section. In case of any doubts, just let me know. But if you have thoroughly practiced the first three classes, now you will be able to think or imagine the basic linked list program, of course. So today's class will be just a revise class, just to check whatever we have done, will that be enough to write few more programs. So we have three topics today, three basic topics. So the first topic is to explore some new programs of linked list. So for the first one, we can choose something like this: find the sum of alternative nodes. So what do you mean by that? If something comes in your question paper or something, you can see some kind of challenges like this. So what do you mean by alternative nodes? So it is something like, suppose they have given 10, 20, 30, 40, and 50. So you have to do something like 10 plus 30 plus 50. So alternative node, you do not need to consider 20 and 40. Okay, so from 10 you have to jump into 30, and from 30 you have to jump into 50. So okay, if I just first try to write the program. So this is our linked list program where we have created all those programs in our class. So if I go to display, just to today we will just reuse whatever we have already done. So we have done couple of programs already, good amount of programs I can see. So if I just copy, because I am a lazy person, so I prefer to copy and paste. So I will just do something like alternative sum or something. So in that case, if head is null, obviously list is empty. How can you going to calculate the sum? Obviously that makes sense. And otherwise, if there is something, what I'm going to do, I'm just going to take a variable, local variable in sum equals to 0. No, temp will be starting from head, temp, until the temp goes to null. And each time temp will jump from temp dot next to next. What does that mean? That means, okay, sorry, some problem with my charger. So what does it mean? Means from 10, it will not go into 20. Temp dot next means 20. It will go to temp dot next. That means directly into 30. So that might be a way to calculate the sum of alternative nodes. So very simple. I hope you can imagine that. It is not like the first class, like you are totally blank, like what we are writing and something like that. I hope it is not now. So that will be enough. Obviously, all the programs are new and you have to think in all the cases. Even now, even means when I see some new for loop programs, obviously I have to think on that. It is not like I can write it in 2 minutes. So, but the thing is, linked list was totally a new topic, but from that area now it might be you have started to understand that. So if I compile that, I think we are good, no compilation errors. So if I just go here and just try to create a new linked list with my name, say Deb, or Deb, whatever, just a short name. And if I just try to insert at end, where is insert at end? Yeah, here it is. So I'm just inserting 10. I'm just inserting, okay, it is still running. Yeah, I'm just inserting 20. just inserting 30, say 10, 20, 30. So it should show me 40 as a result. So if I check void some alternative nodes, you can see it is showing some alternative node as 40. So now there might be few confusions as well. 10, 20, 30 is working well, but what if I give 10, 20, 30 and 40? So if I do that, let me test if it is still working or not. If I check, yeah, look, it is still okay. So it is a simple program just to check the alternative node sum. So I hope you can imagine that if any case of any problem, you can tell me. So if something is given like delete second element, we have already done deleting the first element. Now it is done the deleting the second element. How can you think about that? So again, if I can copy something, let me check. Copy the idea or something. Okay, delete. Where is delete? Yeah, if I copy this, delete from beginning. This time delete from not beginning. This time I'm going to delete the second element. So here if I write delete second, say. So in that case, obviously, if head is null, there is nothing, list is empty. Obviously, how can I delete something if it is empty? Obviously, the second option, I will add another story. Like if there is only one node, it might be the situation there is only one node. So it might be written like this: if head next equals to null, if there is only one element, there is nothing after head, then I will say there is only one element. Very simple. Else, if there is two elements, then I'm going to delete something. So how I can delete? So just let's imagine. So if I just or something, so like this, suppose I have 10, 20, 30, 40, something, some nodes like that. I'm just drawing this picture very casually because I know you are good enough to imagine now. It is just a block. It creates some images in our brain. That's why I'm just writing this. So something like this. So the first node is always head, and our target is to delete the 20. Okay, in this case, obviously, it might vary situation to situation. So something like this. And we are planning to delete 20. So how to do that? So obviously we have checked if the list is empty or not, something like that. But now what I will do, I will put temp on the second position. And then, okay, let me write simultaneously. So there is a node temp equals to head dot next, something like that. Okay, let me delete these lines, unnecessary lines probably. So obviously, at last I will say temp data is deleted, means 20 is deleted. But before that, if I can do something like this, if I can erase the link between 20 and 30. Suppose if I can erase this one, the link between 20 and 30, that will be best. But if I do that, 30 will be lost permanently. So I cannot delete that first, but before I need to create a link between 10 and 30. So if something, if I can do something like this, that will be the great one, just to avoid 20 and make the direct link between 10 and 30. So that line can be written in this way: head next equals to temp next. So head next will point to the node which is currently pointed by temp next. So directly I can write head next equals to temp next, and this green line will appear. And obviously there it will be overridden the link between 10 and 20. So this is the current situation. So at last what I will do, I will just going to write temp next equals to null. Again, it is already done. If you start from head, it will anyhow go to 30. So if you display, you are not going to see 20 anymore. But again, we are a good programmers. So we are the good programmers. So it is good to totally remove 20 ethically. Otherwise, if you display in this situation, it is not going to show 20 anymore. But still, we are going to delete 20. So in that case, if I write temp next equals to null, so what it will do, it will erase the link between 20 and 30 like this. And now you can print temp data is deleted. And after that, if you write temp equals to null, that means temp is going to be removed. Something like that. Okay. So by mistakenly, I have removed the temp later as well. Yeah. So it will look like this. So I think this might work well. Okay. In case of any doubt, you can tell me, or you can recheck this part of the video. So if I just compile and try to run, just to check if it is working properly or not. So if I just create another thing with my name, another linked list object. So now if I start inserting, suppose 10, let me insert another 20. Let me insert another 30. And the last element, let me insert something like 40. 10, 20, 30, 40. Just like the picture, if I display, it should show me 10, 20, 30, 40. Perfect. So now this is the time to delete the second element. We have done a quite lot of programs. So yeah, delete second. So you can see 20 is deleted. Okay. So if I just try to delete once again, this time 30 should be deleted. The second element, 30 is deleted. Perfect. And if I delete again, so 40 will be deleted because 40 will be the second one. Yes. Now we have only one node left. If I show you. So now only 10 is left in the linked list. So now if I try to delete another time, it should show me like there is only one element. How can I delete the second one? So perfectly working this logic. Perfect. So if I just erase this, or just let me go back to the slides. So that is our topic one. I hope you are able to understand how the things are going for linked list now. So now we have seen a couple of programs. So these are the easy one, I believe now at this moment. So topic two, writing algorithm, how to write the algorithm. Obviously, it is a big question from the starting in the colleges, because everywhere you can see like in the question, they will be asking for the algorithms. But why algorithms? It is something new or something tough? Obviously, no. So if I just took a sample program like delete from beginning or delete the first element, some programs like that we have already written that program. So if I just go to linked list, and this is the program, delete from beginning, or you can say like delete first element. So in writing algorithm is not a tough thing. Okay. People think like it is a tough one, but trust me, in exams or in interviews, they ask for algorithms just to minimize the complexities of the program. Because now, at this moment, this program is probably few hundred lines. You can see it is quite long enough. So people might be afraid of writing long programs. So that's why they prefer like, okay, write only some part of the program. Now, again, if they ask for writing a program, that will be also tough because you cannot mistake even a semicolon. If you forget to give a semicolon and if you try to compile, there will be an error. You can see. So just a semicolon out of hundred of lines, out of thousand of letters, just if you miss one semicolon, that is not going to be done. So that's why interviewer make the things easier for you. So they say it like, okay, do not need to write the exact program. You do not need to be the perfect to put a semicolon as well. So it will be good as well if you can explain that. If you can explain what you are going to write. Even if you can write a pseudocode, whatever you can follow. So for this one, there is another problem, another rumor or another misconception I have heard in my tuition career. Like people says like, okay, there is a way. I have written this algorithm in this way, but I have seen in my school or in my college they have written the algorithm in some different way. Let me make the things very clear to you. There is no specific rule of algorithm. Now you are going to attend this YouTube class, you are going to see a lot of videos available in here and there. But previously, when we all were based on books, at that time no one can explain the things to us. So algorithm is something. Suppose you have to make another one of your friend, you want to make him or her understand about some Linkedlist program. So you cannot talk. Suppose you have to write a letter or something. In that case, you will be trying your best to explain him or her about some program by writing in your own way. So that is algorithm. Now some people says like, okay, what if I share the entire program? Obviously, now just imagine on the very first day, if I just share this program, suppose delete from position, and if I share this big program to you, and if I say like, okay, try to understand. Obviously, it doesn't make sense. Obviously, most of the people will be afraid. Apart from some tech savvy people, they like the code very much. They are obsessed with that, except those people. For most of the common people like us, will be afraid, like, what is this? What is this big program about? But if you try to make him or her understand in simple way, like if you write something in words, like if head is null, then print list is empty. If position equals to 1, then you can see like, okay, it is something like delete from beginning. If you explain each line, that will make more sense. And that is the algorithm itself. Okay, so if I go back to delete from beginning, where is that? Yeah. So delete from beginning is very simple. If head is null, list is empty. If it is not, mark something temp at head. Okay, if I just remind you what we have done at the time of delete from beginning. If I go back to our original linked list, here it is. So what we are doing, node equals to temp. So temp equals to head, we are going to mark temp here. Then what it is doing, head equals to head next. You can see head is moving to the next node. So head from here, it is moving to 20. That was the program itself. I am helping you by explaining the things. The code itself is sometimes, most of the time, it is not enough to explain to someone new. So I am just explaining. Head goes to the next node, and then temp next equals to null. That means you have to remove the connection between 10 and 20 like this. And after that, you are printing temp data is deleted, and then temp equals to null. That means you are saying 10 is deleted, and after that you are just removing everything from temp. So now if I try to check, I was trying to put some of the famous linked list programs here, famous sites, websites. You can check any websites. Okay, it is not like you are checking my classes, you cannot see, means you can take knowledge from anywhere. So just let me remove the drawings. Yeah. So if I just try to check any of the famous websites for the algorithm, you can see they followed different ways. That doesn't mean this one algorithm is correct and another one is incorrect. It is not. You can write it in your words. Okay, so there is no specific rule. So here you can see delete from beginning, they are saying point head to the second node. That's all the algorithm is. That means they are saying no need to do this kind of things. It will also be enough if you just do this. And it is true. It will work if you remember our first class, or if you do not remember even, if you just do this head equals to head next, it is going to work. So they are explaining it in words. You can try this. It works. Okay. So they are just explaining like move head to the next node. That's all. That's their algorithm is for delete from beginning. Take a look. Okay. So algorithm, one another thing, algorithm has no language as well. Okay. So algorithm is just a simple explanation. You can follow that in your way in Java. It is not about coding. You can follow that in C, C++, in any language. So if I check another famous website like Java T Point, what it is saying, you can see it is saying pointer equals to head, head equals to pointer dot next, and something it will work. They are saying an algorithm, they can explain something like if head equals to null, write underflow. We have written list is empty. So in your words again, and then they are saying go to step 5. They have written the algorithm in step 1, step 2, step 3 in that format. So they are saying go to step 5. Step 5 is exit. So you can follow this way as well. Nothing wrong or nothing good in those. Okay. And if it is not null, then set temp equals to head. They are saying it as PTR or something, whatever it is. Head equals to head next. They are saying set head equals to head next. So set is not a specific language. Okay. So it is a common English word. And after that, they are saying free PTR or whatever we have done, something similar here, like where is the program? Here we have done temp equals to null. So they are trying to say like remove PTR or remove temp, something like this. Okay, so you can follow these wordings, this step 1, step 2, whatever you like. So if I show you another websites, just I'm trying to show you like it is just your own words. If you can express yourself in words, just express. So something again, delete first node here. Where is that? So. Okay. Here he has written something like this. Create a temporary pointer that initially points to the head. Head moves to the next node. Delete the temporary pointer. Return the lineage. So basically these 3 lines mainly. Look in very simple words. So you can check randomly. It is not like I'm trying to manipulate or something. You can try to check any simple way of algorithm. Okay. So let me check the last one. Just I was randomly searched this in Google and I got them in a first place. That's why I'm just pasting them. So you can choose your own. You can just write the same thing, delete from beginning and algorithm. So just check how they have written. So here they have written something like save the reference of the first node. That means they are trying to mean like, okay, put something like temp into the head, move first pointer to the next node, move from the first node to the next node, and deallocate memory the saved node. That means the first one. So delete the temp one or something. So you can explain it in your own way. You can write it in that way, like step 1, step 2, or you can simply say like, okay, move to the next node. That means you are deleting the first node, something like that. So this is also called algorithm. Okay. So even if in front of the interviewer, if you are good with the code, you can write the code even. So no matter, they will not going to judge you. Writing code is tougher because you have to take care of all the semicolons and every small things. But writing algorithm is easier because you just need to explain in your own way. There is nothing wrong or nothing correct. So if you can express yourself, you can make the people on the other side understand with the concept, then it is a fine algorithm. Very simple. Okay. So that's the thing I wanted to discuss on this last class of single linked list, because from the next class I'm planning to move into the double linked list. So the last topic for the day that I wanted to discuss with you. some innovative programs like the array. We have done something in the classes of arrays, like shifting the array. So if I just think about shifting the linked list to the left, what I'm trying to mean with an example, suppose we have an linked list with 10, 20, 30, 40, 50, and I want to make them move into the left side. You can see if all of them move into the left side, it will be something like 20, 30, 40, 50, 10. So I'm just trying to move it in this way. So look, 10 will go to the last and 20, 30, 40, 50, 10, something like this. So how you can achieve that? So you can write an algorithm or whatever. So if I just explain it. So if I just try to explain it here. So first you have to write something like this, delete from beginning. I can write an algorithm like this, delete from beginning. After that, save the deleted node, and then means I'm talking about 10 I have deleted, and I'm saving that node and add it to the end of linked list. So I'm just adding it at the end. So as a result, it seems like everything will be shifted to the left. You can see. So that will be the very simple algorithm. Even if you want to write it in a step 1, step 2 basis, so something like that, step 1, um, uh, temp equals to head, something like that. Step 1, temp equals to head. What would be the step 2? The step 2 will be something like temp next equals to null. I'm just trying to write it in purely technical way. Temp next equals to null. That means the link between 10 and 20 I'm going to cut. And step 3, reach to the end of list. I'm just trying to reach at till the end, like 250. And then I'm trying to recreate the link and like add temp at the end, something like that as a step 4. So that might also work again. If you are able to understand, it is good. If you are still in doubt, then I can write the program for you as well, if that works. In case of algorithm, in front of the interviewer, you can write the program itself, if that makes sense. Okay. So the actual definition of algorithm is express yourself. But nowadays we have changed it. We have make it complicated. We have made some rules, unnecessary rules, but algorithm is really something that is free from all these rules and everything. So suppose if we have an linked list looks like this, suppose, and let me draw it very quickly, something like this. Okay, just some problem with my drawing, probably, yeah. So here, something like this, yeah. So now if I just write it like 10 here, here 20, something 30, 40, 50. And now, okay, so let me first copy something. Okay, let me not be lazy this time. Let me write something like void shift left, something like this. And what I am going to do first, temp equals to head, obviously. So your var equals to head, something anyway. So let me write something like node temp and node var. So I'm just going to write something var equals to head. So something I want to do like delete from beginning, something. Okay, I forgot to mention moving the head in my algorithm. Okay, so that also will be included in those lines. So suppose I just put var equals to head. So var, I'm pointing var to the first node. And then what I'm doing, I'm just going to move head into the next position like this. If I just erase it, yeah, so head into the next position. And now what I'm going to do, obviously removing the link between 10 and 20. So I'm just going to write like this, var next equals to null. So let me write it in the program itself. Var equals to head, then head equals to head dot next. And after that, var next equals to null. So I will achieve into this position at that point of time, like 10 is separated from 20. And now what I'm going to do, I'm just going to introduce a for loop where temp will be starting from new head, that is 20. It will be executed until temp next not equals to null. I want to reach till the end. So temp equals to temp dot next. And I put semicolon. Semicolon means it will be an empty loop. As a result, what I will get, the temp will reach till the end. And the last task will be to link temp with var. So if I just write temp dot next equals to var, it will serve the purpose. So that means at the very end, I'm just linking 50 with 10. That's all. So basically what I'm trying to do, if I just try to draw, so here 50 will point to 10. So that means 10 will be placed at the end. And the linked list will look like 20, 30, 40, 50. So again, whatever you like, if you like to write the program, that is good in front of the interviewer. If you like to explain in words, that is also good. So it's up to you. Okay, algorithm makes our life easy, not tough. So that is the misconception. So if I just try to run this program once, just to check if I have made any mistakes or not. So again, with my name, if I create one linked list, and where is that inserted ending? Yeah, here it is. So if I just randomly insert few, okay, sorry, my computer is super slow. You can see. Just to insert one thing, my computer is taking a hell lot of time. So again, so 20, the next term. Let me wait for make this process completed. Okay, so if I just write 30 and the last one as 40. It is taking a bit longer time. Yeah, so the last one is 40. So now, if I want to shift, where is the shift one? I have recently created, yes. Shift left. I am going to click that. Here it is. And it should be shifted left. So now if I display, it should start from 20. You can see. So it is like 20, 30, 40, and 10. So it worked. So again, you probably understood like how the algorithm is being written. Even the new concept, new kind of programs like this, shifting and all, you will be familiar with this. So that's pretty much of it from our linked list journey. Better to say a singular linked list journey. So you can find an exercise in this Facebook group with a name. There will be an album with the name like data structure exercise. You can find the singular linked list exercise there. In case of any problem, just let me know. And from the next class onwards, we will be starting our journey for the double linked list. And trust me, that will not be going to be tough. If you have the program of single linked list, we are just going to transform them into the double linked list. So it is going to be very easy. The first three classes were the tough. So I will suggest you just to go through and practice all those programs. And if in case of any problem, just let me know. I will try to help you and I will try to check like where you have done the mistake. So you can paste the program in the comment section as well. So I can have a look. So that's all for the day. See you in next class. Bye.